can your power supply handle the socket A? That's always an interesting question and hotly debated in various retro forums. Here we've got a little test setup that we're going to use today. At the moment the power reading is around 150, 160 watts. Now that doesn't sound like much. Most modern power supplies 300, 400, 500 watts. So where's the problem? Well, the problem is that the socket A system draws most of the current from the 5-volt rail, and unfortunately most modern power supplies have a fairly weak 5-volt rail compared to older power supplies. They usually have something like 15, 16, 20 amperage, whereas older power supplies have close to double that. So what does that mean? Well, what we're going to do in this video is try out a bunch of components, see how much power it draws. We're going to swap a ton of power supplies, and we will try to push the power supplies to the limit, see if something breaks, see if something blows up. That's what this video is all about. So here we've got the system running with the CPU fan disconnected, no RAM, no graphics card. This is with the Duron 600, and we're getting a power reading of around 40 watts. So when I plug in the fan, the power reading goes up to 43. However, this is from the 12-volt rail. So we can basically say that the CPU fan consumes around 3 watts of power, but that is from the 12-volt rail. So let's add some memory. We're going to install 2 sticks of 1 GB DDR400. Now, 2 sticks should consume a little bit more power, but we will find out just how much. But also remember, this is all under idle conditions. Okay, so here we go with 2 sticks of memory. 44 watts is the reading. Alrighty, let's add a video card. I've got a bunch of video cards actually lined up, so I'm gonna start with a GeForce 2 Ti. So here we go. We can see the power reading fluctuating between 60 and 61. I'm gonna go with 60 because it stays around that figure for most of the time. So that's 60 watts for the system with the GeForce 2 Ti. So with the GeForce 3 Ti 200, we're getting a reading of 57 watts. So that's a 3 watts less than with the GeForce 2 Ti. So with the GeForce 3 Ti 500, we're getting 67 watts. So far this is our most power-hungry video card. And the next card we have is the GeForce 4MX 460. I believe this is also the quickest GeForce 4MX, and we're just going to wait for the power reading to settle down, but it appears we have 49 watts for this card. So this is the lowest reading we got so far by quite a long shot, to be honest. And we're also going to test some ATI cards. This is a Radeon 7500 from Sapphire, so let's have a look how much power this card consumes. So 45 watts, so that's fantastic. Very low so far, it's the lowest. 4 watts less than the GeForce 4 MX 460. So with the Radeon 9600 XT, we're getting 49 watts, so that's very good as well. So that was a quick rough test. We just tried out a few graphics cards, and the differences are quite impressive. We're getting a delta of around 20 watts between the video cards. So the Radeon 7500 and the MX 460 and the G-Cube 9600 XT, they're all quite power efficient, and without a doubt the most power hungry card is the GeForce 3 Ti 500, and that's the card we're going to go with because the idea is to push this to the limit. We're going to swap out a few processors and see how the system reacts and if we can get the power supply to actually turn off. So let's quickly add a hard drive. We've got our reading of 69 or 70 watts. So let's just quickly plug in the Molex and we'll see the power draw go up. Now hard drives are quite interesting. The data sheets tell us that it consumes power from the 5-volt and from the 12-volt rail, so it went up by around 6 or 7 watts. However, this is split up. I had a look at the data sheet. Around 4.8 watts come from the 12-volt rail and only 2.4 watts come from the 5-volt rail. Under usage, when we're using the drive, the 5-volt rail only gets used with around 3 watts. So 3 watts is the worst case scenario affecting the 5-volt rail. So here we are on the Windows desktop. We're getting a reading of 91 watts. So let's take that figure and let's go with 90, and I'm going to subtract 5, 6, 8 watts for the fan and for the hard drive. So we've got a reading on here of 82 watts to do with the 5-volt rail, and we also got to take into account the efficiency of the power supply, so I'm just going to go with 85%, so we just multiply that figure with 0.85, and we're getting a reading of around 70 watts. So that should be the real figure, and 70 watts is still quite a bit away from the 100 watts before we're seeing any trouble. Okay, let's run some benchmarks. We've got 3D Mark 2001, and we're just going to run it and keep an eye on the reading and see what the maximum is. So this has been running for a while, and the maximum I saw was around 104 watts. So let's just punch in the numbers. We've got 104 watts. So let's subtract 8 watts for the fan and for the hard drive. We're getting 96 watts on the wall. Let's multiply that with the power efficiency of 0.85. We're getting a wattage of 81.6. So that is still well within the capacity of what this power supply can deliver. So we're going to shut it down and upgrade the CPU to something more powerful. So I've replaced the processor. We've got a Duron 1000, which has close to 50 watt of a TDP. So it's a lot more power hungry. So let's turn it on and see if anything interesting happens. So yeah, we're not getting a screen. There's also no post beep. So basically the machine is not turning on. So I've got a suspicion with the graphics card. So I'm just going to shut it off. And we're going to put in the Radeon, which used a lot less power. And we'll see if the machine will then post. There you go, that was the post beep, and let's see if we get a screen. Yes, there you have it. So yeah, it looks like we already ran into the limitations of this power supply, going from the Duron 600, which is it's rated as having around 25 of a TDP, to the Duron 1000, which has a 50 watt TDP. So those extra 25 watts resulted in the machine not turning on. So that's kind of where the limit is, which is good for us to know. So the reading we saw first under load was around 104 watts. So if we add 25 to that, that's a reading of around 130, which we would have gotten had the Duron 1000 actually posted just fine. However, we can't test it, but let's keep that figure in mind. Around 130 watts seems to be the limit for this system. Okay, so I swapped the processor again. We're going with something that's in between the two. It's the Duron 800 with a TDP of 35 watts, and I've got the GeForce back. So let's see if we can get this processor to actually turn on. So this one is also not posting. Seems to be also a little bit too much for this power supply. So it looks like we ran into the limit of the SFP Hexa 500. So I swapped the power supply. We're using a Corsair VS450. Now this one actually has a lower 5-volt rating, only 16 amps. But yeah, look, that's what you came here for. So maybe something will blow up or something interesting will happen. And if you don't try it, you'll never know. So let's fire it up and see what happens. There you go, it actually posts. So, well, what can we take from this away? Basically that the power supply ratings, I don't know, don't tell the whole story, maybe there's more to it. But we've got something to benchmark now. So we're going to put into Windows, run 3D Mark, see what the highest rating is, and see if we can make it crash or do anything interesting. So the highest reading I saw was around 122 watts, so that is around 18 watts more compared to the Duron 600. Well, I guess we're going to keep going. I'm going to shut it down, and we're going to put in the new processor and see how far we can push the Corsair VS450. So the next processor is the Duron 1000. Now this one has a TDP of 46.1. So let's see what happens with this processor. Wow, So machine also posts. Well, I guess we're going to boot into Windows, run 3D Mark again and see if anything interesting happens. So the highest I saw on the Dragon benchmark was around 135 watts. So let's type that in, subtract 8 watts for the CPU fan and for the hard drive, we're getting 127. I don't know how efficient that power supply is. I'm just going to go with the same 85 percentage. So we're getting a power reading of 108 watts. So that's well over what the rating of the power supply is, but it looks like it's got a lot of headroom and a lot of extra capacity built in. So we're gonna shut it down and on to the next processor. So the next processor is the Athlon 1000. That one has a higher frontside bus, 133, which with double data rate to 266, and that's got a TDP of 54 watts. So let's see if the Corsair power supply can handle this processor. Looks like we reached the limit of the Corsair now. It also does not post. So interesting question for you guys. What is actually stopping the machine from posting? Is it a safety feature built into the power supply, or is it something to do in the motherboard, reading the voltages and deciding not to continue? So yeah, looks like we ran into the limit. I'm gonna swap the power supply for an older model, which has a 35 amp rating on the 5-volt rail. Okay, here we go. Old school power supply with a 35 amp rating on the 5-volt rail. Interesting is the 5 to 6 watt reading not even turned on. So let's fire it up and see if anything interesting happens. So yep, the machine posted just fine. Good to go. So we're going to boot into Windows, run the 3D Mark again and have a look what the top reading is during the Dragon part of the benchmark. So I did see 140 at least once on the power reading. So 140 watts peak load, and the power supply handles it fine. So yeah, on to the next processor with a little bit more power demand. So this processor is a retro beast of a CPU, 72 watts of TDP. It is of course the Athlon 1400. So it's all fired up, ready to go, fresh thermal paste. Let's see if this power supply can tame this beast. Yep, it posted just fine. Quite a high reading, I just saw 146 there. So it will be interesting to see what the maximum load is once we run the benchmark. Now I'm seeing readings close to 160 watts. I saw 160 watts just now. Now do keep in mind that the efficiency of this power supply is obviously totally different than the other one, so we can't really compare them. However, we can definitely see that an old school power supply that has a beefy 5-volt rail has no problem handling an Athlon system with even the top processors. And look, that shouldn't really be a surprise. These power supplies were built to do that task back in the day. So the question really is, what do you trust more, an old power supply that was manufactured to do this job, or a more modern power supply, but you're running it close to the limit or even beyond? And that's definitely some interesting discussion, hopefully down below in the description. So I'm trying to summarize this project a little bit. Hopefully you find some interesting data or information in this video that can be applied to your project. The FSP power supply was rated on paper much stronger than the Corsair. However, even with the Duron 800 it wouldn't post. Another thing we can take away, that Corsair power supplies seem to be very decent. Maybe they're over-spec'd, over-engineered, but definitely for the Athlon, for a retro gaming machine, they seem to be a really good choice. The choice of video card can have a huge impact on power draw, and that's where more tests, more experimentation is necessary. Maybe a GeForce 4 or FX is even lower power than the GeForce 3 Ti 500 that we're using in this project. So for those of you who are building a Socket A retro gaming PC, the power supply issue is real. Do check the ratings on your power supply, do check what components you have, maybe get yourself one of these power meters. They're not expensive and they can help you diagnose any issues. Now if you're building a Socket A retro gaming PC and you're sticking with a fairly low power processor, you can look at the Wikipedia lists to see which ones are low power. Choose a slightly low power graphics card and you should be fine, even with a modern power supply that does not have the strongest 5-volt rail. However, if you're dead set on building a high-end Socket A machine, you've got a couple of options. One is you get a beefy old-school power supply, but the problem is of course age, wear and tear, and I have known a lot of people where the power supply went bust, it blew up basically and took a lot of retro parts to the grave. So that is always one of my worries, and that is the reason why I prefer to use modern power supplies. Now you have an option if you have deep pockets and you can spend a little bit more. If you go for one of the high-end power supplies like Corsair 1000 or whatever, I put in a screenshot of that power supply. It has a 30 watt amperage rating on the 5-volt rail, so that power supply should also be good to go, but you're looking at $300 around that figure. And one more recommendation I have to people who are looking at building a high-end Socket A system is don't do it. Go with the Athlon 64 instead, which has the 4-pin auxiliary power connector and everything runs from 12 volts. So yeah, if you're really dead set on a Socket A machine with high-end parts, you will definitely have to solve the power issue. And yeah, sometimes it's just wiser to ditch a project and go with the smarter option, which is the Athlon 64, which is power efficient. It's called Cool and Quiet, and it uses the 12-volt power rail from the power supply, so a lot easier to work with. There's one more option, and that is finding a Socket A motherboard with a 4-pin power connector. The jury is still out if really every Socket A board that has such a 4-pin connector will draw most of the juice from the 12-volt rail. I haven't really found a nifty gadget that you can just plug in between the motherboard and the ATX connector to really figure out where the power draw comes from. But that's another option, and a lot of retro people are doing that. I've got such a board, but I don't have enough time to test this, so maybe that's something for another video. So yeah guys, there you have it. Lots of information, lots of interesting stuff. Unfortunately nothing blew up. All the power supplies stopped basically turning on. Really interesting to know if it's the motherboard that stopped the machine from turning on, or if it's a safety feature built into the power supply. But I think we've got a lot of interesting things here to talk about below in the comments. Share your experiences with power supplies and the Socket A platform, and yeah, really eager to hear what you guys think. And that's it for this video guys. Thank you so much for watching, and I shall see you soon with another video.